so far, multiply, divide, add, and subtract rational expressions. And then in 9.5, we looked at the characteristics of rational functions. And today in section 9.6, we're going to look at rational equations. So a rational equation is just an equation that contains at least one rational expression. So that's what a rational equation is. Okay, so what is it? What is a rational equation? Okay, it must contain one rational expression. So we worked with rational expressions in 9.1, 9.2, 9.3, and 9.4. All of those were rational expressions. Okay? And how do you solve it? So how do you solve a rational equation? Okay? So the first thing you do is determine the common denominator. Okay, and then once you have done that, you're going to multiply both sides of the equation by that. Okay, so once you determine the common denominator, you multiply both sides of the equation of the equation by the common denominator. Okay, when you do that, you eliminate all of the rational expressions, because when you multiply by the denominator, that means that you can cancel that denominator out and you no longer have a fraction. You no longer have a rational expression. You are left with either a linear equation or a quadratic equation, both of which we already know how to solve. So step 3, you solve the resulting equation, which will either be linear or quadratic, both of which we already know. Okay? So after you have done that, you have to check your answers. Okay? Why do you have to check your answers? Because you need to look for extraneous solutions. So extraneous kind of sounds like extra, right? So extraneous solutions are solutions that if we were to put that solution back into our original problem, either the equation doesn't work or we get an undefined rational expression, so we're dividing by 0. So either way, the solution doesn't work and we call it an extraneous solution. So let's look at an example following these steps on how to solve a rational equation. So we're going to look at example 1, where we have 18 over x minus 6, and it's equal to 6. We have to solve, right? So we're trying to solve for x. So first thing that I always do anytime I'm working with rationals is that I identify my groupings. So for example, this x minus 6 is a grouping. It has to have those parentheses on there. So then I identify my common denominator. I only have one denominator, and that's x minus 6. So I need to multiply both sides of the equation by x minus 6. Okay, and once I do that, x minus 6 will cancel this x minus 6, leaving me 18 equals 6 times x minus 6. So for here, I'm solving for x. This is a linear equation. So first thing I'll do is distribute the 6. So now I have 18 equals 6x minus 36. And then I'll add 36 to both sides. So now I have 6x is equal to 54, which means, if you divide both sides by 6, then that means x is equal to 9. All right, and then I have to check. I have to make sure that this answer is going to work. So I substitute it back into my original problem. So my original problem was 18 over x minus 6 equals 6. But instead of saying x minus 6, I'm going to say 9 minus 6. And then I'm going to see if it works. 9 minus 6 is 3. And then 18 divided by 3 is 6. So this checks. All right, so make sure that you check your answers, okay? And another way to check our answers is to just look at what we have and think, if this was a function, would it be in the domain, okay? So, for example, I know my domain has to be, because this is x minus 6, it can't be 6, right? So it can be any other number except for 6. So because it says not 6, it's 9, that means it's going to work. Okay, so that's another way to check your answer other than substituting it and checking it. If you just consider, what's the domain? What can x not be? And then once you determine that, you can check your answer that way as well. Okay, so let's look at another example. So this one will just be a little bit more complicated or complex. We're going to do 12 over x plus 1 equals x minus 3. So first thing that I always do is put my parentheses in. So x plus 1 needs parentheses and x minus 3 needs parentheses. So I identify my common denominator. The only denominator that I have is x plus 1. So I'm going to multiply both sides of the equation by that denominator, x plus 1. Okay? Why do I do that? I'm killing my fraction, right? I want my denominator to cancel out. Okay? Once I have done that, I'm left with 12 equals x minus 3 times x plus 1. So now I actually have to multiply x minus 3 times x plus 1. That is going to require either the FOIL method or the box method. So looking at my box here, so I have x minus 3 and I have x plus 1. X times x is x squared. X times negative 3 is negative 3x. X times 1 is x. Negative 3 times 1 is negative 3. So I have x squared. X minus 3x is negative 2x. And then I have minus 3. All right, so this is a quadratic. So the first thing I want to do is I want to set it equal to 0. That's how we solve a quadratic equation, right? So I subtract 12 from both sides. All right, and so now I have 0 is equal to x squared minus 2x minus 15. So remember, there are multiple ways to solve a quadratic. You can either factor, you can use the quadratic equation, which is x equals negative b plus or minus square root square root 4ac all over 2a. So the quadratic equation, x equals negative b plus or minus square root b squared minus 4ac all over 2a. So you can use that to solve for x, or you can factor, or if you use your calculator, you might be able to find answers using your calculator as well. So I will do all three ways so that way you can see it. Okay, if I factor this, I'm looking for x squared, negative 15, and it has to add up to negative 2x. So that's x and x. So negative 15, but adds up to negative 2. Let's see. 3 and 5, and then we could make the 5 negative and the 3 positive, and then that way it'll add up to negative 2x, right? Because negative 5x plus 3x is negative 2x. So now I have 0 equals x plus 3, x minus 5, right? Which means that I can use my zero product property that says that if this times this equals 0, then x plus 3 equals 0, or x minus 5 equals 0, which means x equals negative 3, or x is equal to 5. All right, so we can also check our answer like by doing the quadratic equation instead. So remember, our a would be 1, our b would be negative 2, and our c, we're looking at this equation, right? After we subtracted 12 from both sides. So this is not a and b. So a is 1, because there's a 1 there. B is negative 2, and c is negative 15. So we have negative b. So b is negative 2. So we have negative 2, which is positive 2, plus or minus. Negative 2 squared, which is 4, minus 4 times a, which is 1, times c, which is negative 15, all over 2 times 1. So x equals 2 plus or minus. So this becomes 4 times 50. 15 is 60, 64. So square root of 64 is 8. So 2 plus or minus 8 divided by 2. So 2 plus 8 is 10, and 10 divided by 2 is 5. 2 minus 8 is negative 6, and then negative 6 divided by 2 is negative 3. So as you notice, we got the same answers as if we were to factor it, because it's just another way to solve a quadratic equation. The last way I want to show you sometimes works and sometimes doesn't. It's if you use your calculator. Remember, we're just trying to see what x is equal to, right? When y is 0. So if we use our calculator and we go to y equals and we plug in our equation, so it was x squared minus 2x minus 15, and we take a look at the graph, we're trying to see where y is 0, what is the x value. So when y is 0, that means we're on the x-axis, and you can notice it's at negative 3 and it's at 5. So that's a third way to solve a quadratic equation. Okay? And then also quadratic equations have been covered this year as well. So we're in chapter 9 right now. And so if you need a refresher on quadratic equations, you can go back to chapter 4. And that's when we actually learned all of these methods to solve for quadratic equations. Okay, so last step is to check our answers to make sure that none of them are extraneous. So remember, our original problem was 12 over x plus 1 equals x minus 3. So we know x cannot be negative 1, and neither of them are. So that, just by looking at the domain, that tells us that they're safe, okay? And that means that they are both solutions, all right? So we're going to look at one more example now. So this is our last example. We have x plus 2 over x minus 4 equals 30 over x minus 4x plus 1 plus 4 over x plus 1. Okay, so first thing that we do, let's put some parentheses. This x plus 1 actually did not have parentheses on it, but I went ahead and added them because it's just natural for me. This x plus 2 needs parentheses, and this x minus 4 needs parentheses. All right, so now we're looking for a common denominator, right? So the common denominator for this equation would be x minus 4, x plus 1. That is the most common denominator. So this guy is missing x plus 1. So we'll multiply both top and bottom by x plus 1. This guy is covered. He has both of them. But this guy is missing x minus 4. So we will multiply by x minus 4. All right. Very good. So from here, notice that now that we have a common denominator, if we want everything to cancel out, we still need to multiply by an x minus 4, right? So we'd have to multiply x minus 4 here. Okay, and over here we had to multiply x minus 4, x plus 1. Okay, and then over here we would have to multiply by an x plus 1. Okay, so in the end, whatever that common denominator was, notice how that ended up having to be multiplied by everything in the numerator. So that's the key. Whatever your common denominator is, okay, eventually, once you get the other denominators to match it, when you try to cancel the denominator, what you're going to end up doing is just multiplying everything by that common denominator. So, in the top, what we are left with is we are left with x plus 2, x plus 1. All right, and then we are left with 30. And then over here, we're left with the 4. And we're left with an x minus 4. Okay, so the reason why is because we had this x plus 2. This x minus 4 canceled this x minus 4, but we still had this x plus 1, so it had to be multiplied here. Over here, everything canceled, so we just have the 30. Over here, the only thing canceled was the x plus 1, which means that we had to multiply by an x minus 4. Now, from this point, we need to multiply everything out. So this can be done with the FOIL method or the box method. We can do FOIL for this one. So first terms would be x squared, outer terms would be 2x, inner terms would be x, last terms would be 2. So we get x squared plus 3x plus 2, and then we have our 30. We go ahead and distribute this 4. So now we have plus 4x minus 16. So now we move everything over to one side because it's a quadratic. We want it set it equal to 0. So we're going to subtract 30 and then add 16. And then we're also subtracting 4x. So 3x minus 4x becomes negative x. And then we subtract 30, add 16, add 16. So 2 minus 30 plus 16, we end up with negative 12. So we have x squared minus x minus 12 equals 0. I'm just going to factor that. So x squared negative 12 equals negative x. So 3 and 4 can be multiplied together, and if I make the 4 negative, that will add up to negative x. So I have x plus 3 and x minus 4 equals 0, which means x equals negative 3 or x equals positive 4. Okay, so now I check my answers. So remember, my original equation, I had x minus 4 on the bottom and I had x plus 1 on the bottom. So that means that x could not be negative 1 and x could also not be 4, because if x is 4, then I'm dividing by 0 and that's not good. So if I look at my answers, we do have an x equals 4, which means that that's an extra answer. We can't use that answer. So that means our only answer is x equals negative 3. All right, go ahead and try some problems on your own.